Okay guys, welcome to your notes. Today we'll be talking about our fifth, I believe, and final exponent rule. Okay, so this is going to be our power to a power rule. Okay, so this is the only exponent rule we're talking about. Our last exponent rule we're going to talk about before you guys have your review and then take your tests on exponent rules. Okay, so the first thing we want to do is actually define what is power to a power rule. Okay, you might remember this from last year, but if you don't, that's totally okay. We're going to go over it now. So let's say we have x squared. Okay, we have a power. There's our first power. But now our power is also going to, let me zoom in a little bit, sorry. Now, focus. Beautiful. Okay, so that's our first power, but now it's going to be to a power. Okay, you're always going to see a lot of parentheses in these. That means everything inside is now to a different power. We'll say cubed. Okay, so now let's actually write what's happening here. We have x squared to the power of 3. Okay, we're going to expand this to see what's actually happening. Okay, what this is really saying is we have x squared times itself 3 times, or x squared times x squared times x squared. Okay, so now notice we don't have any power to a power anymore. We're just dealing with product rule. Okay, so with product rule, okay, so now we have product rule. So now we need to simplify using our product rule, which means we are adding up these exponents. We have 2 plus 2 plus 2. Okay, so let's take it one chunk at a time. 2 plus 2 is 4. 4 plus another 2 is going to be 6. So total we have x to the 6th power. Okay, so that's what's actually happening with power to a power rule. But if you want the quick and easy way, think multiply. Okay, so whenever you see power to a power, you're going to think multiply. Meaning, I have, write it in this one, I have x squared to the power of 3, or cubed. What we're going to do is you're going to take that 3 and you're going to multiply it. X to the 2 times 3. Okay, what does that give me? What is 2 times 3? Great job. X to the 6th. Okay, so we got the same answer. Beautiful. Okay, so that's basically our definition of what's happening with power to a power rule. So let's do some examples. So notice, like I said, in fact, let's make a note on the side of our paper. Let's come over here and let's make a note, because you're going to see a lot of parentheses. So parentheses means everything inside. Okay, so make that note on your paper. Parentheses means everything inside. Okay, so let's go back to number 2. So the first thing you're going to want to identify is the exponent on the outside, okay, the power to a power rule. So this 3, that's our to the power. Okay, let me zoom in just a little bit more. Try not to shake the camera too much. Okay, so we see that this 3 is our to a power. Notice it's everything inside our parentheses. So this 3 has to multiply to every exponent. Every base has an exponent. So it multiplies by the 2 and the 4. Okay, so let's take our first base of 2. So 2 to the power of 2 times 3. What is 2 times 3? That first one is going to be 6. Okay, now it's being multiplied by our second base of 2. Now it's to the power of 4 times 3. What is 4 times 3? 12. Beautiful. Okay, this is not our simplified answer because I see 2 of the same base, 2 of these 2's. So now we need to use product rule to simplify, meaning I have 2 as my base, and now I can add my exponents. 6 plus 12. Okay, what is 6 plus 12? What is 2 going to be to the power 2? It's going to be 18. And there is our simplified answer. Beautiful. Okay, skip number 3 because this is kind of a trick question. Is there even a power to a power? Is this, and yes, write this on your paper. Totally just changed my mind. Is this power to a power? Do you see any parentheses? No, this is literally just product rule. Okay, it's only being multiplied. So we're gonna skip 3. But now let's go to number 4. So do you see parentheses hinting at, is there going to be a power to a power? Yes. Okay, so I see some parentheses, and I see that that's to the power of 3. Okay, so this 3 needs to multiply to each base, so 2x and y. Okay, but you might say, well, what are the exponents with 2 and x? Okay, what are those exponents? What is the creepy exponent that's always there? It's to the power of 1 and to the power of 1. Sweet. So now we can take our 3, and it multiplies by each base's exponent. So this one's going to multiply 3 times. So let's just take it one step at a time. So we have 2 is our first base. Okay, it's going to be to the power of 1 times 3. What is 1 times 3? That is just 3. Okay, x is our next base. Also to the power of 1 times 3. Just 3. Okay, y is our last base. Now it's to the power of 2 times 3. What is 2 times 3? Good job, that is 6. Okay, and now it's just being multiplied by what's left. We don't have to take this to a power, right? We don't see any parentheses. So we just have x and y squared. Okay, so now I see a base of 2, I see a couple x's, and I see a couple y's. So we need to combine these, simplify them somehow. Okay, so we know that 2 to the power of 3 is going to stay the same, right? There's no other bases of 2 that we can combine that with. But now we see some x's, right, in this x. So I have 3 x's right here. I have 1 right here. How many x's do I have? Or 3 plus 1? X to the 4th. Great job. Now it's last one. Y's. I have 6 y's right here. I have another 2 y's over here. So I have y to the 8th. And now that is simplified, right? I only have one of each base. 1, 2, 1 x, and 1 y. Nice. Okay. Let's skip number 5. Don't feel like doing it. So let's go to number 6. Okay, so notice that we're now dealing with fractions. That's okay. Okay, we're going to treat it the exact same way. So first thing, you need to find your power to a power. So I see the parentheses, and this whole thing is to the power of 3. Okay, what is that 2 to the power of? The invisible number? To the power of 1, right? So now I can say this 3 is going to multiply by that 2 and that 1 to give us our denominator. Okay, so let's figure out our denominator first. So 2 is going to be our base to the power of 1 times 3, which is 3. Okay, b is our next base to the power of 2 times 3, which is 6. Great. Okay, simplifying up top. So what do we need to do to simplify up top? I see a 2. I don't see any parentheses, first of all, so we know it's not power to a power. Okay, I see a couple a's. Those a's we need to combine. So let's just write our 2. Okay, but now let's combine our a's. So I see 4 A's right here. I see another 2 right there. Okay, how many A's do I have on top? 4 plus 2. I have 6. Okay, now what's left over on top? B squared. Okay, are we done simplifying? Meaning, do you see only one of each base? No, I see these two bases and then 2 B's. So we need to combine these somehow. Okay, how do we combine them when they're being divided? Or think quotient rule. What do we do with quotient rule? Okay, we're gonna cancel things out or simplify them. Okay, so let's start with our 2's. So I have 1 2 on top. I have 3 2's on bottom. One of them is going to cancel out, right? 1 2 over 3 2's. How many 2's are going to be left on bottom? Or 3 minus 1. Great job. 2 squared. 2 2's are left on bottom. None are left on top. That one canceled out. Okay, so now let's look at our B's. So I have 2 B's on top, 6 B's on bottom. 2 of them are going to cancel out. How many will be left on bottom? Great job. 4. B to the 4th, or 6 minus 2. Okay, A, that's the only A I see, so that one's already simplified. So our final answer, A to the 6th over 2 squared times B to the 4th. Great job, you guys. Okay. Let's do number 7. This looks big and scary, but it's really not. Okay? So we see that this 3, this whole power, it's all in our parentheses. So this whole thing is to the power of 3, right? So this is a power to a power rule. We're just going to have to multiply it a lot of times, right? So first of all, this 2 is to the power of 1. That 2 is to the power of 1. And this V is to the power of 1. Okay? So now that we got those invisible exponents out of the way, now we can multiply that 3 to everything it needs to multiply to. Okay, so it needs to multiply to the V, the U, that 2, okay? Also that other V, that other U, that other 2, last one, that V. Okay, we're just going to take it one step at a time. Okay, so let's take our 2, our very first 2 first. What is 1 times 3? Beautiful. 2 cubed. Okay, our first U, what is 4 times 3? 12, good job. Might need a little more room. Okay, our first V, what is 3 times 3? Great job, 9. Okay, now we're on to our second 2. What is 1 times 3 again? Okay, again, 2 cubed. Our second U, 4 times 3. Again, U to the 12th. Our last V on top, 2 times 3. 6. And our very last V on bottom, what is 1 times 3? V cubed. Okay, nice job. We got rid of the power to a power. Now we just need to combine some stuff. Okay, so I'm going to bring it down here. Okay, so let's combine some stuff. So the first thing I see that I can combine are these 2's, right? They have the same base. So I have 3 2's right here. I have another 3 2's right there. How many 2's do I have, or bases of 2? I have 3 plus 3, which is 6. Great job. We got rid of our 2's. Okay, now let's look at our U's. We'll use a different color. Let's use this pink. Okay, so I have 12 U's right here. I have another 12 U's right there. Okay, how many U's do I have? U to the power of 24. 12 plus 12. Great job. Okay, now I'll use blue for V. Okay, so I have 9 V's right here, 6 more right here. So what is 9 plus 6? v to the power of 15. Okay, last one, v cubed. Are we done? Are we simplified? Do you only see one of each base? Nope. Okay, notice we have these v's. Okay, we need to simplify the v's. Okay, so let's do this in red. Okay, so 2 to the power of 6 and u to the power of 24, those are the only ones of those base. So those are going to stay the same. Okay, but I have 15 v's on top. I have 3 on bottom. 3 of those are going to cancel out. How many will be left on top? Great job. 15 minus 3 is 12. Okay, nothing's left on bottom, so do I have to write the 1? Nope, when it's on bottom, you do not have to write the 1. So that is our simplified answer. Okay. We are going to, so we skipped 5. Let's just write this out so you don't have to. We skipped 5. I actually want to skip 8 and 9. And we're going to go straight to number 10. Okay, because this is going to remind us of another rule we talked about. Okay, so the first thing you're going to want to see, power to a power, right? Where are your parentheses? Okay, and I see this power of 0. So meaning the whole thing, everything inside, right? Parentheses means everything inside is to the power of 0. Okay, what is anything to the power of 0? In fact, we're going to make a note. Anything to the power of 0 is what? Good job. It's 1. So that whole piece right there just turns to a big fat 1. Okay, so now you can write what's left on bottom, 2yx squared. Okay, and on top we have x cubed and y to the negative second power. Ooh. Okay, so we need to get rid of this negative second power. Do you guys remember what we do when we have a negative exponent? We switch it. So that negative exponent is going to attach to what's right in front of it, right? And it's going to switch, meaning on bottom, we now have this 1, which do I need to write this 1 if it's being multiplied? Nope, it can go back to being invisible. So on bottom, I have 2yx squared that was already there, but now this negative 2 switch places. Now it's y to the positive 2. Great job. What was left on top? Just x cubed. Beautiful. Are we done? Okay, do you only see one of each base? No, I see a couple x's, I see a couple y's, so we need to combine those. Okay, so let's combine the y's first. Okay, so I have 1y right here. I have another 2 y's right there. So how many y's do I have on bottom? 1 plus 2 is 3. Okay, now let's combine the x's. I have 3 x's on top, 2 on bottom. 2 of those are going to cancel out. How many will I have left on top or bottom? Where is it going to be? I'm going to have 1 x left over, right, on top. Okay, or x to the power of 1. We don't really need to write the 1. It's invisible. Okay, and the last thing that was left over was that 2. And that is our simplified answer. Beautiful. Okay, your notes should look like mine. We skipped a couple, so that's okay. You don't need to have those filled out. Okay, but you should have your notes all filled out in order to get those participation points. You don't need to turn them in. I'm just going to come around and check to make sure you have them filled out. If you are doing this assignment from home, This paper will be all filled out and linked for you on Canvas. Okay, so you'll just have to do your assignment. Okay, awesome. Bye, you guys.